WPA2 applies different encryption algorithms to further secure communication. When using WPA2, the process goes as follows. The connecting device makes itself known to the access point. The AP sends a pseudo-randomly generated nonce to the device as plain text. Then the device generates its own pseudo-random nonce.
Yes. Now the device then uses these two nonces, the MAC address of the AP, the MAC addresses of the device, and the PSK as input to a cryptographic hash function to create a block of keying information called the pairwise temporal key, or PTK, which is 64 bytes or 512 bits in length. PTK is cut up to produce 5 separate session keys. Now the key configuration key, KCK, is 128 bits long. The key encryption key, KEK, 128 bits, the temporal key TK, 128 bits, and 2 shorter keys, RX and TX, used for providing message authentication codes, or MACs, both 64 bits long.
The device now responds to the AP with its own nonce, concatenated with a hash of the AP's nonce that it received and the KCK. The AP derives the same PTK and session keys as the device, so it now holds the same input information, nonces, PSK, and MAC addresses. It can then hash its own nonce with the derived KCK and then check it against the one that it received. This confirms that the device shares the PSK and is now authenticated to the AP. The AP responds to the device with a hash of the device's nonce using the KCK and a sequenced number to prevent replays of previous messages by an active hacker.
Yeah, the device checks the received hash of its own nonce against the expected result with the KCK, and if they match, the AP is authenticated to the device. Now, the device responds with an acknowledgement of receipt, and the handshake is then completed.
That's right. Now, from this point onward, messages between the AP and device are encrypted using AES with the TK derived by both devices. The RX is used to create MACs on messages sent by the device, and the TX is used to create MACs on messages sent by the AP.
Mm-hmm.